Hi, my name is Ryan Harris for thisbridgeistheroot.com. Today, I'm going to be covering DMVPN configuration, starting with GRE point-to-point and moving on to GRE multipoint. In another video, I'm going to cover DMVPN phase 1, 2, and 3, as well as routing protocols and further configuration. As you can see in my lab here, I am running 3 routers in Cisco Modeling Labs. They are the Cisco IOL image, which is iOS XE on Linux. This is available in version 2.7 of CML. Router 1 is my hub router, and I have router 2 and 3 as my spoke routers. Each router has an Ethernet 00 interface with the address 10.0.1, and it's a /24, so 1, 2, and 3. And then the tunnel interfaces are going to be 10.55.0, so 1, 2, and 3. As well, I have a loop back. Let's get started. On router 1, I'm going to do a show run interface of tunnel 1 so that I can get an idea of what's configured. So I just have an IP address configured on tunnel 1. I'm going to need to configure both a source and destination for this tunnel 1 in order to get it to talk to spoke 1 or router 1 or router 2, excuse me. So I'm going to set tunnel source ETH00 and a tunnel destination of the underlay network, which is 10.0.1.2. And you can see my tunnel interface came up. On router 2, I'm going to do a show run interface tunnel 1. And just like before, I'm going to set a tunnel source and a tunnel destination. And again, my tunnel came up on router 2. I can ping now between router 1 and router 2. That's the IP address, 10.55.0.2. And you can see I'm able to ping across. GRE is a very simple protocol. We could do more, but this isn't encrypted currently. We'll cover that later on. Right now, we just have those two. Those are a point-to-point. We're going to set up a point-to-point between router 3 and router 1 now. So go on router 3. We're going to look at our tunnel 1 interface. Again, I've got 10.55.0.3 configured as the address. I'm going to set a tunnel source and a tunnel destination as well here. So I can ping the underlay. Cut that. I can try and ping 10.55.0.1, but it's not going to work because the tunnel interface is mapped to the IP address. So let's take a look on router 1. We're going to do a debug tunnel on router 1. And then we're going to go back to router 3 and ping again. And you can see here we have some error messages, tunnel drop, failed to find tunnel for GRE IPv4. And that packet is 10.0.1.3. Basically, the router is unable to map the address to a tunnel because we already have a tunnel on router 1, or between router 1 and router 2. So what we need to do is go under we're actually going to create a second tunnel called tunnel 2 on router 1. We're going to give it the address 10.55.2.1, and that's a /24. We're going to make it a tunnel source and tunnel destination. Tunnel source is ETH00, and destination is the 10.0.1.3 address of router 3. On router 3, I'm going to have to go and change the IP address of the tunnel interface. So before it was 10.55.0. So let's set the IP address on router 3 to 10.55.2.3. Typed enter too quickly. Make that a /24. And now make sure that we can ping across to router 1, which we can. The problem with these point-to-point links is that the configuration need expands the more spoke routers that we have. We would prefer to have a single interface on our hub router that connects to all of our spoke routers. If we had dozens or hundreds of spoke sites, our configuration would get out of hand very quickly and become very unmanageable. So let's change the router 1 interface to a GRE point to multipoint. But first, I'm going to go on router 3 and change the IP address back to the 1055.0 network. So that address is 1055.03, and that's a /24. Then we're going to go under router 1 and delete the tunnel 2 interface first. And let's go under the tunnel 1 interface. We want to change the mode to GRE multipoint. But if we do this without removing the tunnel destination, it's going to give us an error message. We need to remove that. So we just do a no tunnel destination, and now we can go up and set the tunnel interface to mode GRE multipoint. I'm going to turn off debug as well, just so that we can see this a little clearer. I'm going to do a show run int tunnel 1 so that I can see we have GRE multipoint. In this version of code, I'm not sure about older versions, it automatically adds the no IP redirects command when you change to the mode GRE multipoint. I did not add that as you saw before. It's just automatically added. So let's see if I can ping across to router 2. So that's 1055.02, and that's going to fail. The reason why it's failing is we do not have a mapping of where 1055.2 is on the underlay. So in that, we need to create an NHRP static map. So NHRP is sort of an ARP-like protocol that maps tunnel IP addresses to the underlay address. In NHRP commands, that's called an NBMA, so that's non-broadcast multi-access. It could be a serial network. In our case, it's an Ethernet, but in most cases, it's going to be the internet. So the internet is an NBMA network. So let's go make that mapping. We're going to do config t interface tunnel 1 IP NHRP map. That's 1055.02, and that maps to the NBMA address. And I can see, you can see here under the context sensitive help, they call it NBMA. So that's a 10.0. I messed up here. Not 10.0.11. It's 10.0.2. 10.0.12. Excuse me. So let me fix that. And then for spoke 3 or router 3, we're going to set 1055.03 to 10.0.13. When you do show DMVPN right now, you're not seeing anything. And the reason why that is that when you do show DMVPN here, you're not seeing any commands. And when I try and ping across to that static map, it's not going to work. And the reason why that is that NHRP needs to be started. NHRP has sort of a process, or sort of similar to OSPF in a way, where it's a locally significant process that just needs to be started. So I'm going to go under the interface and type the command IP NHRP network ID 1. And you can see now when I do show DMVPN, I see both of my static mappings under the interface. Let's see if I can ping across. So 1055.02, ping across, and 03, I can also ping there as well. Now I'm going to go on router 2 and try and ping the hub router, which I can. and ping the other spoke router. So that's router 3, and I can also ping there. But it's something worth noting that that traffic isn't going directly between router 2 and router 3. It's actually being relayed by the hub router. So it goes up to router 1 first and then back down to 3. And then that reverse process is also true. It goes back up to 1 and down to 2. And the problem with that is that the bandwidth on router 1 is now doubled. As well, we probably don't want that traffic to take an inefficient route. In a production network, that may be undesirable. So we want router 2 and router 3 to just be able to form those tunnels automatically between each other. We'll get into that in DMVPN phase 2. And we'll also, when we talk about DMVPN phase 1, we'll talk about simplifying the configuration that we have here a little bit, where we don't have to do NHRP static mappings as well. So for now, my name is Ryan Harris, and I'll see you in the next video.